Now let's talk about power in an electrical circuit. We know electrical energy is very useful because it is so easy to convert it from one form of energy to another. We have motors that transform mechanical energy into work. You have heaters, stoves, hair dryers, etc., that transform electrical power into thermal. And light bulbs transform electrical power into visible light and thermal. Now, what's interesting is a light bulb only converts about 10% of the energy it gets into visible light. The other 90% goes into thermal. If you don't believe it, try grabbing a light bulb that's been on for a while. Now, this is another reason that the the energy efficient and cool bulbs are becoming so popular. Remember, power is the rate at which work is done or energy is converted. And electrical work is the rate at which electrical energy is converted, or the rate of energy transfer. So, how does electrical energy get to your house without you losing most of the energy along the wires? And the answer is the wires are made to have as small of resistance as possible. Remember that the longer your resistor, the more the resistance. And just go outside and look. You can see very long wires. So we have a very low resistance wire, if at all possible. Also, they tend to try to send as low a current as possible with a high potential difference. So we only lose small amounts of energy. Now, power plants can transport electrical energy very long distances, um, and they use very large voltages, nearly 80,000 volts. Now, you can't handle 80,000 volts pumping into your house. When the electricity reaches the city has transformers, which reduces it to about 4,000 volts. Now, the transformers are those funny looking things on the poles outside. And in Houston, we have a lot of problems with squirrels getting into our transformers and blowing out our power. When the power gets to your house, you have another transformer that reduces it to 120 volts. Now, this is what comes out of your wall outlet. You would have zero chance of being able to run your toaster on 76,000 volts. It would blow out at 4,000 volts, but 120 volts, you can make a piece of toast. Remember the formulas, my Piv and Veer story. The power is IV, or it's I squared R, or it's V squared over R. Now look at this. If it travels at very large voltages and low currents, because this current is squared, this shows you we're going to lose a lot of energy for the same resistor, okay, if when the I is squared. All right.